So the next session is about, is basically, we called it ongoing research and upcoming features in Charm++. We will talk about some of the things we have released recently so that everyone is aware of it, and then, or some things that we are working on for future. And then I want to open it for discussion for people from PPL members as well as outsiders to ask about or ask for features and optimizations. Oh, is it there? Okay. There are a couple of things we'll begin with. First, I will have Xiang talk a little bit about the out of core execution stuff that she has been working on for some time, and then we'll have Sam talk about the version 6.7 and 6.71 features, and then we'll discuss more broadly for a few minutes.
Okay, can you hear me? All right, I will talk about the Charm++ support for out-of-core computation. As you can see from the graph on the left-hand side, here we show the memory to flop ratios for the recent computers. It keeps decreasing from 0.25 to less than 0.1. Another trend is that SSD are becoming more and more flexible, especially in the next generation supercomputers. You would expect more widely use of SSD. What we want to do is to leverage the runtime system to prefetch data for the computation task that resides in SSD. Meanwhile, we overlap the I/O activities with useful computation. Here we show the system design of it. In the scheduler queue, we would expect different computation tasks. Some may need data that is in the which such as the external memory as SSD, and some tasks may already have all the data available in the DRAM. The role of the runtime system is to prefetch the data, for example, for task 1, task 2, while executing task 3, where the data is already available. We have different optimizations implemented, such as scheduling tasks based on availability, and we leverage the knowledge about the data effects to further reduce our activities. Also, we mitigate the load imbalance caused by data availability with on-node parallelism. In this graph, we show the user API. As you can see, the change we made in the CI file is to express the dependencies between the computation task as well as the data. And in the user, in the C file, the user right now needs to express, allocate data using a different I/O handler, using a different data type, so that the runtime system is aware that the data can be put on both either SSD or DRAM. We have some initial results. These experiments are conducted on Comet, a machine in San Diego Supercomputing Center, which already has SSD on each node. So this experiment is using the matrix multiplication program, and on the x-axis we show the different ratio of available memory, which means we limited the memory available to the user compared to the total memory requirement. On the y-axis we show the normalized time compared to the execution time when all the memory is available. And we compared the performance of using the Charm++ runtime support or using the Linux IMAP interface for out-of-car execution. As you can see, with the CHARM++ support, it scales very well, even when the available memory drops below 6.25%. However, with the Linux IMAP interface, the performance decreases quite a lot. So in the future, as Professor Kale mentioned, we want to add support for the high bandwidth memory in the for the Xeon Phi next landing machine. Here, the DRAM will become the slow memory, while the unknown memory will become the faster memory, and we want to leverage the runtime system for better communication between the faster memory and the slow memory. That's all what I have.
All right. Thank you. Sam? Oh, any questions about this part? In particular, we would like to know about applications that need out-of-core-like things. I mean, Sang at the beginning talked about the fact that we have the bytes per flop is going down and down and down from needing a balance factor of 1 to now about 0.05. Of course, the machines themselves are becoming big, so the flops are getting faster, but the bytes are also getting larger. And so maybe the models fit, but I think there may be models where people want to fit much larger models, and then this SSD-based things will be very useful. So if people know of such models that require a lot more memory than the machines have available, it will be useful to know.
Okay. So we just wanted to recap developments in the recent CHARM++ releases that have happened since our last workshop in last spring. So in the winter, we released CHARM++ 6.7.0, and this release contained over 120 bug fixes spanning areas across the entire system. And in particular, we had some new features. CK Loop is now, our loop level parallelism library is now built by default with CHARM. And we added a new API for creating sparse char arrays based on regular formulas. User code no longer needs to call cbase foo pup from the actual char array element pup routine. And in AMPI, we furthered our MPI 2.0 standard compliance. And then we have a new build for ARM, and you can build CHARM out of the actual source tree now. And we're now set to release CHARM++ 6.7.1 tomorrow, which is going to be a bug fix release for CHARM and a feature release for AMPI. So on the CHARM side, we've seen improvements to the startup and exit sequences, and some different fixes for portability and platforms. In addition, we have more informative error and warning messages during startup and related to different features. And for AMPI, we have renamed our extensions to the MPI standard with the AMPI underscore prefix, and we now officially support MPI 2.2 and have some of the features of 3.1 implemented. Okay, and that's it.
Great, thank you. So at this point, I want to just open for discussion for people who want to state some of the points that our users should know, as well as people, as well as anyone who wants to talk about what they want in CHARM++. Yes.
Are there any plans to support OpenSHMEM?
As a implementation target, wasn't there one? OpenSHMEM was one there, and we dropped it. That's my okay.
There would have been the original SHMEM many years ago.
It's too many years ago.
So there are machines that where this would be useful.
OpenSHMEM is very active, I think.
Are there machines where it is the fastest way to push bits over the network is the question. Because, okay, in that case, we would probably resurrect it. Right now, the machines we run on are usually either the proprietary Cray or
does SGI? Well, SGI or shared memory machine.
OpenStream is supported by InfiniBand.
Well, okay. So the question would be: is it lower level than? Is it closer to the hardware than the InfiniBand verbs API that we already implement? No. And just to follow up on that, we do have in progress an Open Fabrics implementation provided by Intel being reviewed for integration with mainline right now. So for Intel's OmniPath interconnect and Cisco's UCS and a few other targets, those should be the vendor preferred absolute fastest possible network interface.
672.
Probably 6, 8 later in the year.
This is implementation done by Intel, and it works on their clusters, but there are some other clusters where we have seen problems, and Cisco clusters we've seen some problems. So it may be fast if Cisco pays attention to it, or we can release partially for Intel clusters.
Can I ask what is the difference in terms of performance between MPI target and verbs target?
I can tell you for the SMP builds is a much larger benefit to use verbs than for non-SMP builds.
But
I had an experience. I built SMP and MPI, and I actually didn't on my application saw any improvement in SMP.
well, the MPI is not beneficial; it is worse, right? So that's what you experience. Also, MPI is not that good.
SMP is. I expected to get an improvement in performance when I use SMP build,
Oh,
and then I didn't have.
So SMP versus non-SMP really depends on whether your application is exploiting the shared memory within the node. As soon as you go to an SMP build, you have one communication thread per process, so you lose a core for that, as opposed to having basically each process is its own communication thread when it needs to communicate. So it depends how well the underlying network hardware relates on that. So if you take non-SMP and you compare verbs to MPI, verbs may be a little bit faster, but it's marginal. When you go to the SMP build, verbs is significantly faster than MPI in my experience.
The single node.
Well, in a single node, you just use multi-core and you're done, because there's no communication. But if you have multiple nodes, SMP with verbs will be faster than SMP with MPI.
so there is another thing that we noticed, and in fact, that's one of the improvements we have on mind, which is that if you use SMP version, you have to be careful to use the cores and do the affinities right. And if you have 16 cores, you have to say PPN 15 and leave one core for the COM thread, right? And in fact, those things you as a user have to remember to do. If you don't do it, you'll be oversubscribing the P threads to cores, and you'll get bad performance. And the system needs to detect that and tell you that you're going to get bad performance because of that. And that's one of the things I think we have on cards for to implement, maybe on the Jamwork side.
Yeah, we'll contribute it back. It'll probably be in 6.8.
Okay.
So yeah, the other thing, yeah. So PE math and com math are necessary for performance, and you can really shoot yourself in the foot if you get them wrong. So particularly, I mean, we're playing with power again, and they order the hardware threads differently than Intel does. So if you say, if you just take the first 20 cores, well, that's going to be like the first 20 process CPUs is like 1.5, 2.5 cores.
That's the way the cores are numbered on the hardware is a complicated issue. And in fact, there are reasons for it. The Intel, I believe, you will get the hyperthreads on the second round. That is, you go cyclic over the cores, and then you get the second hyperthread over the larger serial numbers.
Depends on the generation.
Depends on generation. So all of these complexities, we would like to shield Jam++ users from, It's a bit hard to do, but that's one of the things that we will look at in the CharmWorks okay, any other desired features? We have somewhat of an underrepresentation from applications this time because of all the DOE folk who would not come because of various meetings going on. But so maybe there will be fewer. But I think if, this should serve as a user meeting of sorts as well, the workshop. And so if there are no other demands now, we can actually just say that okay, at the time of well, we should have some kind of a chart mailing list or thing utilized for requesting features like that. So keep that in mind and spread the word. Anything else? I think we should expect. You heard about the one-sided thing, the avoiding copy bit, so that the large message performance should be better. We're also focusing on small message performance. You heard from Alexander about what he encountered and so on. We're seeing some of that in our PDES applications as well. Cham++ is reasonably good on fine-grained applications. You saw last year or a couple years ago performance of NAND going to each time step taking about 200 microseconds, less than 250 microseconds per time step, and within that is doing a wide variety of computation and communications. So I think we're doing okay on fine-grained applications, but when you go real fine-grained, like Alexander wants to do or PDES, then we have performance issues. And so in any case, people love to measure things with micro benchmarks and crib. So for that reason too, we would like to improve our fine-grained performance. So that's going to be another thing that's on the cards. There might be changes to the map, the way the map function works, the proc_num function for those of you who use the mapping. And so we will keep some backward compatibility, but we'll have a newer mechanism. Most likely, that's what I'm pushing for. Not that the whole core group has agreed to it. But so those are some of the things that are on the cards. Right? Should we stop here? See, I thought we were going to go over today, and we're doing fine. We've built enough margins into the thing. So we now have free time for discussion. So this is the time. Workshop is also a time for our collaborators to meet and discuss. And because of the talks, we don't. We have very limited time to do that. So this is the time when we can use the time for project meetings and discussions. So use that. 6:30 we'll have the banquet starting right here outside.